Greetings! Blue Origin remains quiet about its investigation into the cause of the New Shepard mishap on Monday. The senior VP for the New Glenn rocket, Jarrett Jones, is quoted by Jeff Faust of Space News as saying the company would not talk about the incident, but that it was a little premature to assume that the engine was at fault. As we noted in our Monday broadcast, the BE-3PM engine in New Shepard is the forerunner of New Glenn's upper stage Hydrolox engine, the BE-3U, and Jones said that there was technology transfer to this upgraded vacuum version. Sierra Space, builders of the upcoming Dream Chaser spaceplane, is also busy with space station module design. They unveiled a dramatic video showing a successful ultimate burst pressure test for an inflatable habitat module known as the Large Inflatable Flexible Environment, or LIFE. The test was sponsored by Next Space Technologies for Exploration Partnerships 2, also known as Next Step 2, Habitat Systems Project, which is managed by NASA's Marshall Spaceflight Center and was performed at JSC. NASA's soft goods subject matter experts and ILC Dover collaborated on the test. The test is the first of two subscale burst tests scheduled for 2022 in support of Sierra Space's soft goods certification and used a 1/3 scale of Sierra Space's LIFE inflatable habitat, which burst at 192 psi, exceeding the safety requirement of 182.4 psi. As a result, this stress test is among the highest publicly released data points for a soft goods pressure test at any scale. Sierra Space will plan the next subscale test for later this year. Subscale tests are used to support the overall full system development and to determine the ability of a vehicle to withstand the maximum internal pressure required to cause failure of the vehicle's pressure shell, commonly known as the restraint layer. Among other missions in coming years, Life Habitat will serve as a habitation and payload element for the Orbital Reef Commercial Space Station, a collaboration between Sierra Space and Blue Origin.
This burst test is what's called a UBP. It's an ultimate burst pressure test. And the reason we say ultimate is because we want to bring it to failure. I'm Sean Buckley, Chief Engineer of Life and Node at Sierra Space. Life Habitat is an inflatable system which is made of a series of soft goods layers. And those soft goods layers, under pressure, deploy to an expandable volume that you can use in space. In preparing the article, there are several things that we want to do. And in that preparation, we take a look at the exterior of the article. We make sure that all the elements are cohesively working with each other. We make sure that the area around the article is going to provide us with the data we want from the test. If we want to keep expanding, and we want to keep moving to new reaches and new heights, we have to embrace technologies that we're not comfortable with. Soft goods is one of those. And soft goods for habitation is a game changer.
LIFE stands for Large Integrated Flexible Environment. It's an inflatable habitat. It's very flexible when it's not pressurized, but once it's pressurized, it is like a rock. And it's stronger than steel, 5 times stronger than steel. The idea is it launches in a packed state, and then when you get on orbit, you inflate it so you have more volume and you have more room to live, work, and function. Hi, I'm Gerard Valle, and I'm the Structures, Mechanisms, and Soft Good Lead for Sierra Space Life Habitat. We're really just testing the structural restraint layer, which is what carries the load, and it's 1/3 the size of a life habitat.
So the restraint layer is made up of a material called Vectran. Vectran is an extremely high-strength material, performs really well in this application. It gets us the best performance while maximizing the livable volume inside the habitat. My name is James Kerwin, and I'm the Program Manager for Habitats at ILC Dover. Years of research have gone into perfecting how it's woven together, how it's sewn together, What this test is demonstrating is that we can achieve a higher factor of safety requirement than even hard structures can.
There's a lot of preparation in order to get the module prepared for test. So right now we're doing a low pressurization. We'll bring it up to a low pressure. A team will go out there, they'll take a look at the system, make sure the architecture looks good, and then we'll start to ramp it up. Take a couple hours for us to get there.
So the goal is 180 PSI or larger. I'm looking forward to the day playing out. And the more margin you get, the further ahead we are. So we don't get to 180 PSI, it's a step backwards. So getting to that first gate is important, and then progressing from there.
This test is important because running models and analyses can only give you theoretical results. You need the hard data to back up the research that we've been doing.
So we have a set of high-speed cameras, and the high-speed cameras are what will capture the actual event. With the high-speed, you'll be able to see exactly where the failure initiated, because it usually starts in one location, propagates throughout the whole test article.
Yeah, let's go! Great day for the LIFE program, great day for ILC, for NASA, our partners, and Sierra Space.
You can design and analyze something, but you don't really know until you run a test. And typically you test beyond the design capability.
Oh, the clever spring. Wow, look at that.
I think we're at an inflection point where the technology is about to be kicked off and utilized, so very excited about the next steps coming up.
The seam is right up here, and the seam is typically the weakest point in the design. So for it to have not failed at the seam is very interesting. And it goes back to wanting to see the high-speed footage and finding out what ultimately caused this.
This is a highly successful test. Our expectations were to meet and exceed the 182.4 PSI, and we burst at 192, which was incredible for us. Pretty amazing.
As reported by Jeff Faust of Space News, ESA's Director General Josef Aschbacher is seeking a 25% increase in spending over the next 3-year member states' budget cycle. Aschbacher, in a speech at the World Satellite Business Week conference, noted that with the end of Europe's earlier dependence on Russian capabilities, funding would be needed to increase European space independence. ESA's Solar Orbiter is back in the news after its recent successful flyby of Venus. With data from its closest pass of the Sun yet, the joint ESA-NASA mission has found compelling clues as to the origin of magnetic switchbacks and points towards how their physical formation mechanism might help accelerate the solar wind. Solar Orbiter has made the first ever remote sensing observation consistent with a magnetic phenomenon called a switchback, a sudden and large deflection of the solar wind's magnetic field. The new observation provides a full view of the structure, in this case confirming that it has an S-shaped character as predicted. Furthermore, the global perspective provided by the Solar Orbiter data indicates that these rapidly changing magnetic fields can have their origin near the surface of the Sun. While a number of spacecraft have flown through these puzzling regions before, those observations only allow for a measurement at a single point in time. Consequently, the structure and shape of the switchback has to be inferred from plasma and magnetic field properties measured at one point. When the German-American Helios 1 and 2 spacecraft flew close to the Sun in the mid-1970s, both probes recorded sudden reversals of the Sun's magnetic field. These mysterious reversals were always abrupt and always temporary, lasting from a few seconds to a number of hours before the magnetic field switched back to its original direction. These magnetic structures were also probed at much larger distances from the Sun by the Ulysses spacecraft in the late 1990s. Instead of a third the Earth's orbital radius from the Sun, where the Helios missions made their closest pass, Ulysses operated mostly beyond the Earth's orbit. Their number rose dramatically with the arrival of NASA's Parker Solar Probe in 2018. This clearly indicated that the sudden magnetic field reversals are more numerous close to the Sun, and led to the suggestion that they were caused by S-shaped kinks in the magnetic field. This puzzling behavior earned the phenomenon the name of switchbacks. On March 25th, Solar Orbiter was just a day away from a close pass of the Sun, bringing it within the orbit of the planet Mercury, and its METIS coronagraph instrument was taking data. METIS blocks out the bright glare of light from the Sun's surface and takes pictures of the Sun's outer atmosphere, known as the corona. The instrument is from the Italian Space Agency. The particles in the corona are electrically charged and follow the Sun's magnetic field lines out into space. The electrically charged particles themselves are called a plasma. At around 2039 UT, METIS recorded an image of the solar corona that showed a distorted S-shaped kink in the coronal plasma. To Daniele Talloni, National Institute for Astrophysics Astrophysical Observatory of Torino, it looks suspiciously like a solar switchback. Comparing the METIS image, which had been taken in visible light, with a concurrent image taken by Solar Orbiter's Extreme Ultraviolet Imager EUI instrument, he saw that the candidate switchback was taking place above an active region cataloged as AR 12972. Active regions are associated with sunspots and magnetic activity. Further analysis of the METIS data showed that the speed of the plasma above this region was very slow, as would be expected from an active region that has yet to release its stored energy. Daniel instantly thought this resembled a generating mechanism for the switchbacks proposed by Professor Gary Zank, University of Alabama in Huntsville. The theory looked at the way different magnetic regions near the surface of the Sun interact with each other. Close to the Sun, and especially above active regions, there are open and closed magnetic field lines. The closed lines are loops of magnetism that arch up into the solar atmosphere before curving round and disappearing back into the Sun. Very little plasma can escape into space above these field lines, and so the speed of the solar wind tends to be slow here. Open field lines are the reverse. They emanate from the Sun and connect with the interplanetary magnetic field of the solar system. They are magnetic highways along which plasma can flow freely and give rise to the fast solar wind. This proved that switchbacks occur when there is an interaction between a region of open field lines and a region of closed field lines. As the field lines crowd together, they can reconnect into a more stable configuration. Rather like cracking a whip, this releases energy and sets an S-shaped disturbance traveling off into space, which a passing spacecraft would record as a switchback. According to Zank, who proposed one of the theories for the origin of the switchbacks, quote, "The first image from METIS suggested to me almost immediately the cartoons that we had drawn in developing the mathematical model for a switchback. Of course, the first image was just a snapshot, and we had to temper our enthusiasm until we had used the excellent METIS coverage to extract temporal information and do a more detailed spectral analysis of the images themselves. The results proved to be absolutely spectacular," unquote. Together with a team of other researchers, they built a computer model of the behavior and found that their results bore a striking resemblance to the METIS image, especially after they included calculations for how the structure would elongate during its propagation outwards through the solar corona. Quote, "I would say that this first image of a magnetic switchback in the solar corona has revealed the mystery of their origin," says Talloni, whose results are published in a paper in the Astrophysical Journal Letters. In understanding switchbacks, solar physicists may also be taking a step toward understanding the details of how the solar wind is accelerated and heated away from the Sun. This is because when spacecraft fly through switchbacks, they often register a localized acceleration of the solar wind. The next step is to try to statistically link switchbacks with their source regions on the Sun, says Taloni. In other words, to have a spacecraft fly through the magnetic reversal and be able to see what's happened on the solar surface. This is exactly the kind of linkage science that Solar Orbiter was designed to do, but it does not necessarily mean that the Solar Orbiter needs to fly through the switchback. It could be another spacecraft, such as the Parker Solar Probe. Here, then, is an ESA video about the discovery. SpaceX and the National Science Foundation are reporting that a new Starlink user terminal is being tested at McMurdo Station, Antarctica. SpaceX says Starlink is now on all 7 continents, and the remote capability in Antarctica is made possible by Starlink's Space Laser Network. The boss of Northrop Grumman's space logistics operation, which is using robotic spacecraft to extend satellite life, tells CNBC's Michael Sheets that while Starship will have awesome capability, it will require in-orbit refueling to reach geosynchronous orbit. This limitation of Starship's near-term potential has not been previously revealed by SpaceX. NASA has announced that it will publish a new Webb telescope image, or spectra, at least every other week starting next week. They issued a statement clarifying the difference between research vetted in the peer review process for regular publication and draft papers posted as preprints. And that's the way space is today. Until tomorrow, ad in explorata toward the unknown in the measureless arena of space. Stay tough and competent, and thanks for watching.
In a welcome relief after yesterday's drubbing, markets posted modest gains. Most of the stocks on the WSN watch list were higher, with Planet Labs jumping an enviable 15%. Momentous, Maxar Technologies, and Astrotech were marginal losers. Reporting from cyberspace, this is correspondent Karen Calvis. Have a great day.